Ladies and gentlemen, this evening speaking tonight is Miss Randy Major. She is going to be speaking to us tonight on how stars are born. So please give a warm welcome to Miss Randy Major.
As Ms. Short said, my name is Randy Major, and I'm here to inform you on the life of stars. Starting from birth till death, yes, stars do die. Have you ever wondered how stars are born and what happens to them after they die? The study of the birth and life of stars are the central focus of astronomy. Stars, like our sun, are being born every day all over the galaxy and in the universe. Stars come in all shapes and sizes and colors. Like right here. They represent the building blocks of every galaxy and solar system in the vast universe. Stars are responsible for distributing heavy elements such as carbon, nitrogen, and oxygen, which are all major contributors to our planetary system. According to James McNeill, a NASA astronomer, stars are born within clouds of dust that are scattered through most galaxies known as stellar nurseries. This is one of the most famous pictures taken by NASA. That's a stellar nursery. And in here you can see little vast lights, and those are where stars are being born. Turbulence within these clouds begin to stir up, and that will ultimately lead to the birth of a new star. The particles found within these clouds are pulled together by gravity. As the cloud begins to collapse, the material at the center begins to heat up. The hot core of the center is a cloud called a protostar. The hot core forms beginning with gathering dust and gas. However, not all of this material will end up as a star. The remaining dust can become planets, asteroids, comets, and just dust. It'll stay dust. A star the size of our sun is about 50 million years maturing from the beginning of the star's life to adulthood. Our sun will stay in this mature phase for approximately 10 billion years. Did you know that stars breathe? Stars are fueled by the nuclear fusion of hydrogen to helium deep in their interiors. So in order to survive, a star must constantly be breathing in hydrogen so it can fuel with its helium. Otherwise, the star will collapse. The outflow of energy from the central regions of the star provides the pressure necessary to keep the star from collapsing under its own weight. And the energy by which it shines is necessary for this fusion to take place. Without the fusion of the two elements, the star would collapse and it would begin a downward spiral towards its death. There are various sizes and colors of all stars, which are given names. The smallest stars are known as red dwarfs. This is at the beginning of its life, this whole star, right here, and this is slightly smaller than our sun. It may contain only 10% of the mass of the sun and is less than 1% of its energy. Red dwarfs are the most abundant species of star found in our universe and have the longest lifespan. Most of the red dwarfs that you can see look like these orange little glowing in this telescope picture. This was taken by the Hubble telescope by NASA. On the other hand, the most massive stars, known as hypergiants, may be 100 times more massive than the sun and give off 100 times more the amount of energy. Here is a red supergiant, a red giant, a blue-white supergiant, and a red giant. These are all, and that's what our sun looks like in comparison to these. Now, because of their size, they live a lot less than they're in the end of their life cycle. So they're beginning to cool off and die out very soon. The larger the star, the shorter the life. Stars breathe in hydrogen like we breathe in oxygen. Without oxygen, we die. So hydrogen fused with helium, stars die. At this time, the increasingly hot core pushes over the outer layers of the star outward, causing them to expand and cool, transforming the star into a red giant. That's the huge, too big to even fit on a piece of paper to show its mass in comparison to the others. That's the whole bottom of this sheet. The star then begins to pulsate and throw off its outer layers. So it's basically destroying itself. It's throwing off its energy into space. It begins to hide itself in a cocoon of gas and dust as it enters in its last stage of life. How the star dies and what becomes of it depends on the size of its core. At the end of the star's life, numerous things can happen. The average star can die and become a white dwarf. This happens to almost all stars. Our sun eventually will turn into a white dwarf if everything goes as planned. White dwarfs are about the size of Earth, and our sun is expected to become a white dwarf at the end of its life. At the end of the white dwarf's lifespan, it either fades away into dust or becomes a nova or a supernova. So after this stage, it becomes a supernova or a nova. It just depends. Now, the difference between a supernova and a nova is just the outer layer of the sun explodes. A supernova is when the whole thing explodes completely. According to Carl Sagan, a famous astronomer, a supernova can outshine entire galaxies for even days upon weeks. This happens about 1 every 100 years, so if you're able, you can only observe it by telescope, but if you're able to, it's definitely a rarity. About 25 to 50 supernovas are discovered each year in other galaxies. However, most are too far away to be seen even with the telescope. A supernova can also create, so the next stage, a supernova can also create a black hole, which is here. You see the stars and then how it kind of fades and there's nothing. That's what it would look like if you looked into the night sky. You'd either do one of three things. It becomes a black hole, a neutron star, where it burns very coldly, so no life would be able to sustain. All the planets around it would freeze. Or a stellar nursery. Basically, their life starts over. So the death of a new star could also become the creation of others. Black holes can form if the core of a supernova collapses completely. A black hole is an infinitely dense object whose gravity is so strong that nothing else can escape it in its immediate proximity, not even light. The dust and breeze left behind by the supernova eventually blend in with surrounding gases and dust particles, and the process starts all over. A new star is born. Thank you. Now I'm going to show you guys a video on YouTube, and so that way you can put what I just said with visuals to see exactly how it happens. Now this is it traveling through the dust of what would be a supernova, a planetary system. It'll take you through the turbulence of what happens on the inside, and there's the whole big picture. And here you see little stars starting to form. Eventually, they basically compete for which one would be they swallow each other up into one. Only one can be produced from one supernova. Here's the gases. Now the energy is being spit out, and it's all the gravitational pull is pulling it all together, so it becomes the core. And the core is developed first. And you'll see as the dust particles begin to swirl around the main core, it'll come back together, and then everything that's left over is what makes up like our Earth, all planets, all asteroids, comets, whatever goes on in the solar system. This is where it happens. It starts with the star first, and then everything else combines together. That's the excess gas and dust, and a planet is born. That's the planet revolving around its sun, or star. At the end of its life, it becomes a supergiant. It gets bigger, and it basically engulfs everything in its path, and everything on the excess will freeze. And a new star is born. It starts over. There's a supernova, goes through its life, and the process begins all over. Thank you.
Bravo, bravo.
Well done.
Good effect with the video, right? Nice.
Are you still recording?
Yeah, actually.